All right, 4.3 slant asymptotes. Okay. We mentioned slant asymptotes in our 4.2 part 2 notes, and now we're going to dive a little deeper. Okay. All right, oblique or slant asymptotes, when do they happen? A rational function has an oblique asymptote when the degree on the numerator, yeah, told me right. On the numerator is exactly 1 degree greater than the degree on the denominator. Okay, so you have an oblique or slant asymptote if a rational function has an oblique asymptote with the degree on the numerator is exactly 1 degree greater than the degree on the denominator. All right, so to find the slant asymptote, we're going to long divide or just divide. So you're going to divide the numerator by the denominator, and your solution is the quotient without the remainder. So just the quotient without the remainder. It's typically going to be, a linear format. When I say linear format, what does that mean? It means y equals mx plus b. Okay, and again, it's without the remainder. So the remainder part is irrelevant. All right, ready? Okay, so find the slant asymptotes if any of the rational functions, and we're going to graph in the calculator C. What we're doing today is we're just only focusing on the slant, but when we put it all together, you're going to have to be able to find every bit of discontinuity, okay? That's the slant or horizontal, the vertical, your holes. You got to be able to find everything. Ultimately is the goal when you put it all together, okay? All right. Here, it says f of x equals x squared minus x minus 2 divided by x minus 1, okay? If we were looking for our whole or anything like that, we would go ahead and factor. But because we're just only focusing on the fact that it has a slant, we do not have to factor. We just want to find the slant asymptote. Does that make sense? And how do I know I have a slant asymptote? Because the degree of my numerator is what? 2, and the degree of my denominator is 1. So n is greater than d, and it's only by 1 degree. Does that make sense? So now we're going to do long division. So we have x minus 1 divided by x squared minus x minus 2. When we're dividing, remember we divide, multiply, subtract, bring down. So what is x squared divided by x? X. After we divide, then we're going to multiply. X times x minus 1 gives me x squared minus x. After we multiply, is it about this? Yeah. Okay. Whoa. The negative x has nothing to do with the degree. The degree is strictly based on the power, the highest power. Okay. All right. When we subtract, that means we're changing the signs and combining like terms. So I subtract, and I'm left with what? 0. And then I'm going to bring down -2. -2 is my what? Remainder, right? So it's -2 over x minus 1. So that's my quotient. Of the quotient, which part is my slant asymptote? Just this piece, right? That's where my slant asymptote is. So my slant asymptote that's all that right? Asymptote. Okay. Is that y equals x. Okay. So to show you graphically what that would look like, I'm going to open the graph. So I'm going to go to y equals. I'm going to protect my I already had it. Dang it. I'm going to protect my numerator. All right, x squared minus x minus 2 divided by, protect my denominator, x minus 1, parentheses protect, and I hit graph. So notice how it's slanting up, and then it curves out. So here's my slant. Notice how there's a imaginary line. So if I was to graph y equals x, I'm going to graph it so you can see it. I'm going to put in y equals x, but I'm going to make it a dashed line so that you arrow over and click enter. So there's my asymptote. And notice how it doesn't cross, it just approaches it. Yeah, no, that's the slant. That's my y equals x. Okay, but it's imaginary. Yes. Yes, because you're dividing by a linear. Okay. All right. Okay, so do we see the difference between a horizontal and a slant? All right. Okay, let's go on to the next example. So here we have 2x cubed plus x squared minus 8x minus 4 divided by x squared minus 3x plus 2. Now, this would be a great and fun time to go over factoring by grouping and then factoring with difference of two squares. But since we're only focused on the slant asymptote, do I have to do all of that factoring? No, I do not. I did try to make sixth period do it, and it just dragged out. So we're not going to do it here. But we're just going to focus on the fact that we realize that the degree of our numerator is what? 3, and the degree of our denominator is 2, and therefore n is greater than d by only 1 degree. Yes? So now we're going to divide. So x squared minus 3x plus 2 divided by 2x cubed plus x squared minus 8x minus 4. So you divide. What is 2x cubed divided by x squared? 2x. After you divide, then you're going to multiply. 2x times x squared is 2x cubed. 2x times negative 3x is negative 6x squared. 2x times 2 is 4x. After I multiply, then I subtract, which means I'm changing the signs and combining like terms. So this cancels out like it's supposed to. 1x squared and 6x squared makes 7x squared. And negative 8x and negative 4x makes. And then I bring down my negative 4. And now I'm going to repeat again. 7x squared divided by x squared is what? 7. In all honesty, can I stop here? I can't. Because all I need is the linear quotient. Do we see that? Do I have my linear quotient? Yes. You don't need the remainder. You just need the linear quotient, which is right here. So where's my slant asymptote at? At y equals 2x plus 7. Terrible? I actually give you the harder problems in our notes, I feel. I give you the harder problems in our notes. I totally do. I don't know why you did that. Shouldn't have taken that long. It was looking at a graph. All right. He looked at a graph and said it took him 2 hours. Are due now today? Okay. All right, here we go. Is there a slant asymptote? Why is there not a slant asymptote? N is less than D, right? The degree of my numerator is less than the degree of my denominator. So instead of a slant asymptote, it actually has a horizontal at what? At 0, at y equals 0. And that's because the degree of my numerator, which is 2, is smaller than the degree of my denominator, which is 3. So I have a horizontal asymptote at y equals 0. Anywho's. Yes. I did not. I did not. I said, It was. I said, I even tried to keep a smile on my face so that I wouldn't be accused. I kept a smile on my face and everything. Anyways, the bullying continues in my 8th period. So here we go. What's happening here? What? N is greater than D, and it's by 1 degree. So what do I have to do? Divide. So we have x squared minus 4 divided by x cubed plus 0x squared plus 0x. All right, here we go. What do I? Oh, I forgot my. Can someone tell me what I forgot in there? My 0x. Pooper scoopers. Yeah. We're just gonna put it in there just so that people can remember to use fillers. Sometimes you don't need it. You don't need it. I just want people to get used to it. Yes, it helps you stay in the pattern, in the routine of putting the filler. All right, here we go. Divide. What is x cubed divided by x squared? X. So I'm going to multiply. That gives me x squared cubed plus 0x squared plus 4x. We divide, we multiply, then we do what? We subtract. And when you're subtracting, that means you're changing the signs and combining like terms. Yes. Where? Oh, in the top, in the bottom? Yeah. There. It doesn't matter. It doesn't matter. It won't matter in the end, I promise. I'm sorry. I think because I know it's gonna be the remainder, it didn't matter. Because you can see it. Here's my remainder. Because can I divide anymore? No. So where is my slant asymptote is at y equals x. This is why we had to learn long division. All right, so we're going to sketch. We're going to put all of our skills together, okay? So in order to sketch, we got to find all of our discontinuities. All right, so the first thing we're going to do is identify whether it's horizontal or slant. How do we know it's slant? Because we already did it, first off. And our N is greater than D. Now, what did we get with this? What was our slant asymptote at? It was at y equals x. So we're going to draw a dashed line at y equals x to represent our slant asymptote. You can't have one or the other because your y's can't be too defined. Yes, vertical is its own world. We did vertical yesterday. All right, here we go. So moving on. Next, in order to find our vertical, we have to factor and make sure it's not a vertical or a hole, right? We did this one already. We did the problem. It was the first one we did. All right, here we go. So I'm going to factor what multiplies to give me -2, but adds to give me -1. What multiplies to give me -2? That gives us x is minus 2, and x plus 1. Do we get to factor anything out? No. So we have a vertical asymptote where? Because we all did, where's my vertical asymptote? At x equals positive 1. So I'm going to draw in my dashed vertical asymptote at positive 1. We found our vertical asymptote. Vertical asymptote comes from your denominator. What multiplies to give me negative 2, but adds to give me negative 1. So negative 2 plus 1 is negative 2. Negative 1. Negative 2 times 1 is negative 2. Our factor rules. All right. Are we in? Okay, so then after we do that, we want to figure out where our curves are. So to find out your curves, you would just take a value. So like I like to use 0. So if I plug 0 in, where is it at? So if I plug 0 into this, where is 0 located at? 0 is at positive 2, right? If I plug 0, 0, 0, right? So if I let x equal 0, I have 0 squared minus 0 minus 2 all over 0 minus 1. So that means it's at negative 2 over negative 1, which equals positive 2. So I'm going to go to 0 and I go to positive 2. So this tells me that my curve starts here and it's working its way. Oh, how did I get there? I don't know how I got there. And it's doing this. But it's never going to touch it. It's just going to keep following it. And on the other side, it's doing the opposite. You have a vertical and a slant asymptote. And there's our sketchy sketch. Okay, hold on. Next week, we're going to be more detailed and find all of our intercepts. So as we get, we're going to then find all of the intercepts. Yes, that's the last piece to make our graphs even better. Right now, it's just a sketch. It's not a perfect graph because we don't have exact X and Y intercepts, but we're going to keep going. All right.